Good morning, children. In last class, we discussed about the rational numbers. Rational numbers which are in the form of P by Q. PQ belongs to Z and Q is not equal to 0. And rational number line. And inserting rational numbers between the given numbers. And we also discussed about the rational to decimal and decimal to rational. Today we are going to introduce irrational numbers. Now please remember the rational numbers and answer me. What is the value of root 25? Yes, it is equal to 5. What is the value of root 16? It is equal to 4. What is the value of root 5? Can you get any rational number? Now we have to discuss about the decimal numbers. What is the value of 1.4? Can we write this as rational? Yes, we can write it as 7 by 5. Is it a rational number? Yes, it is a rational number because 7 and 5 are integers and Q is not equal to 0. Now look at this decimal number. Can we write it as a rational? Yes, it is also written as rational number 125 by 100, which is equal to 5 by 4. If 1.3 bar, look at this number 1.3 bar. Can we write this number as rational? Yes, we can write. Let 1.3 bar is equal to x, 10x is equal to 13.3 bar, x is equal to 1.3 bar. So 9x is equal to 12.0, x is equal to 12 by 9, which is equal to 4 by 3. So we can write the terminating decimals into rational form. We can write the repeating decimals also into rational form. If a decimal number is non-terminating and non-repeating, like 1.3010456975, etc. This is neither terminating nor repeating. Neither terminating nor repeating. So it is not a rational number. So which type of number it is? Yes, it is irrational number. Root 5 is also irrational number. We cannot write the 5 into two equal factors. We cannot write the 5. 2 2s are 4. 3 3s are 9. So we cannot write the 5 into two equal factors. So root 5 is an irrational. 1.3010, etc. non-terminating, non-repeating decimals also irrational. Now look at this number. Cube root of 125. Can you say? It is equal to 5 because we can write 125 as the product of three equal factors. So one of the three factors is cube root. So it is 5. Can you find the cube root of 8? Yes, you can find. because we can write the 8 as the product of three equal factors. One of the three equal factors is the cube root. Now tell me, what is the cube root of 16? We can't say cube root of 16. Cube root of 16. 16 means 2 power 4. We can write the 16 as a product of 4 equal factors. But we cannot write the 16 as a product of 3 equal factors. So it is not a rational number. So if it is not a rational number, if a real number is not a rational number, then it is irrational number. Now we have to discuss the differences between rational and irrational. Rational and irrational. Tell me, what is rational number by definition? Rational, irrational. What is a rational number? Yes, it is in the form of P by Q. PQ belongs to Z and Q is not equal to 0. The number which we can write in the form of P by Q, PQ belongs to Z and Q is not equal to 0 are the rational numbers. What is an irrational number? We cannot write as a rational number. You can say a real number which is not a rational. A real number which is not a rational. It means we cannot write the irrational number in the form of P by Q. PQ belongs to Z and Q is not equal to 0. So this is the first difference we have to say. Rational, irrational. By the definition, it is in the form of P by Q. It cannot be written in the form of P by Q. Next, according to decimals, if the decimal number which is terminating or repeat. The terminating or repeating decimals are rational numbers. Terminating decimal or repeating decimal. We can write terminating decimal in the form of P by Q and also the repeating decimal in the form of P by Q. Irrational means non-terminating, non-repeating decimals. Non-terminating, non-repeating. Next, the set of rational numbers is denoted by Q and the set of irrational numbers is denoted by Q dash. And examples. According to definition, root 9, root 16, 1 by 4 in the form of P by Q is 0.25, 0.32 bar, 0.343434, etc. These are the examples for the rational numbers. It is a rational number because the value of root 9 is 3. It is also a rational number because the value of root 16 is 4. This is a rational number, it is in the form of p by q. This is also a rational number because we can write the decimal number in the rational form. It is 25 by 100. This is also a rational number because it is a repeating decimal. This is also a rational number because it is also repeating decimal. Now, give examples for irrational numbers. Can you give? Yes, root 2, root 3, root 5, etc. And according to decimal form, 0.3435394556, etc. This is non-terminating, non-repeating. So it is a irrational. It is an irrational number. These are the differences between rational numbers and irrational numbers. Can you understand? Note down the differences in your notebook. We will complete it. Now we are going to represent irrational number on number line. Irrational number on number line. First irrational number is root 2. Root 2 is the irrational number. So, we can represent the root 2 by taking this is x-axis, this is y-axis. Take 1 unit on x-axis, this is 1, and take 1 unit. So this is also 1 unit, this is also 1 unit. This is 90 degrees. Now identify the points. This is origin O, this is A and B. OA is equal to 1 unit, AB is also equal to 1 unit. So join OB with escape. What is the hypotenuse of the right angle triangle? According to Pythagorean theorem, square root of OA square plus OB square. OB square is equal to OA square plus AB square. OB square is equal to OA square means 1 square, AB square also 1 square. So OB square is equal to 2, OB is equal to root 2. This is 1 plus 1, which is equal to root 2. So OB is root 2. So take the compass and draw an arc with OB as radius. Draw an arc OB as radius. This point denotes root 2 on number line. Can you understand? First, from the origin, 1 unit. A is 1 unit from the origin. AB is also 1 unit, which is perpendicular to x-axis. Then, according to Pythagorean theorem, OB, the hypotenuse square, is equal to OA square plus AB square. That is 1 square plus 1 square. Here, therefore, OB square is equal to 2. OB is equal to root 2. Taking OB as a radius, we have to draw an arc on x-axis, which gives the root 2. Now, how can we find root 3? Root 3. OP is root 2 and PQ is 1 unit. OP is root 2 and PQ is 1 unit. So what is OQ? What is OQ? OQ is equal to, OQ is a hypotenuse in the triangle OPQ. In the right angle triangle OPQ, OQ is the hypotenuse. OQ square is equal to OP square plus PQ square. OP square means OP is root 2 square plus 1 square. So OQ square is equal to 2 plus 1, 3. So OQ is equal to root 3. OQ is equal to root 3. Take OQ as radius and draw another arc intersecting x-axis. This gives root 3. Take another point, yes. OS is root 3. Thus we can continue the number line. If we want root 5, if we want root 5 on number line. How can we get root 5? Take x-axis and also y-axis. And root 5 means it is 2 square plus 1 square. You know that. 2 square plus 1 square. So this is 1. Here you have to take 1 unit. This is A and B. This is origin O. Join OB. OB gives 2 square plus 1 square according to Pythagorean theorem. OB, hypotenuse square, is equal to OA square plus AB square. This is 1 unit and this is 2 units. So what is the value? It is root 5. In the same process, we have to draw an arc with the radius OB and we get the value of root 5 on number line. Thus, we can represent any irrational on the number line. Now we are going to Insert irrationals between any numbers. Insert irrational numbers. Suppose we have to insert three irrational numbers between 2 and 3. Insert three irrational numbers between 2 and 3. Take 2 and 3. 2 is square root of 4 and 3 is square root of 9. So, we can write root 5, root 6, root 7, root 8. These are the irrational numbers between 2 and 3. Observe, 2 is square root of 4 and 3 is square root of 9. So we can write 4 irrational numbers between the two given numbers. Another process is also there. According to decimals, it is 2.0, this is 3.0. We can write 2 point something, which is non-terminating, non-repeat. 2.3, 4, 5, 6, 9, 3, 8, etc. This is non-terminating, non-repeating decimal between 2 to 3. And another number is 2 point any number which is non-terminating, non-repeating. 4, 2, 5, 9, 6, 8, 2, 4, etc. Write another number between 2 to 3. It means 2.5, 6, 9, 8, 6, 3, 4, 5, etc. We can write infinite numbers between 2 and 3. Can you write? Now, insert three irrational numbers between 4 and 5. Insert three irrational numbers between 4 and 5. What is 4 and what is 5? 4 is square root of 16. You have to remember. 5 is square root of 25. So you can insert square root of 16, square root of 25. You can insert 9 numbers. You can insert 9 irrational numbers between these two numbers. So, in another method, that is decimal number. Decimal numbers means 4 point something, 4 point something, which is non-terminating, non-repeating. Can you write? Yes. Thus, you can write the irrational numbers. If two fractions are given, how can we insert irrational numbers? If two fractions are given, insert two irrational numbers between 5/7 and 7 by 9. We have to insert two irrational numbers between these two rational numbers. First, we have to find the decimal form of the rational numbers. 5 by 7. 5 by 7 is equal to 0.714 2 8 5 5 etc. Therefore, 5 by 7 is equal to 0.7142855. It means 5. Another number is 7 by 9. We have to find the decimal form of the number. 7 by 9. 9 sevens are 63 70. 9 sevens are 63 70. 9 sevens are 63 7. Therefore, it is equal to 0.71. It means 0.777 etc. So we can find two irrationals between 0.71 and 0.77. Can you write? 71 between 71 and 77. You have to remember that. 0.71, 0.77. These are the given numbers. So we have to insert any two irrational numbers between the two given numbers. 7, 1, 3, 4, 5, 6, 2, 9, 3, 9, etc. etc. Non-terminating, non-repeating. We have to keep in mind. The second number is 7, 2. It is less than 7, 7. You have to remember that. 7, 2 and some non-terminating, non-repeating. 3, 5, 6, 9, 3, 4, 4, 5, etc. These are the two irrational numbers between 5 by 7 and 7 by 9. Thus we can insert. Can you understand? First we have to take the values in the decimal form. We have to insert 2 or any numbers between the two decimal numbers. We have to always keep in mind that irrational number is non-terminating and non-repeating. Thus we can answer the question. You can complete 1.2, exercise 1.2. This is assignment. Exercise 1.2. Exercise 1.2. Already we completed 1.1 and now we are able to complete 1.2. So in next class we will discuss about the successive magnification method. Thank you.